Hi everyone, welcome back to Chem Corner. Today I'm coming to you with a lot of energy because a couple of days before our AP Chemistry 2025 results were out. I couldn't be more proud. Almost all of my students, except just two, got a perfect 5 out of 5. And for those two, it's a solid 4. Let's make it even more special. 90% of my students are prepared for AP Chemistry only with me, without even taking the course in school. So I'm really proud of what we have built together here. Back to the point, this video is part of our ongoing basic chemistry series. The things we need to know before you are diving into the actual AP chemistry. Definitely, this is useful for honors chemistry students too. If you're new here, the whole playlist I'm pinning here so you can catch up easily. Let's get in the video. So in today's episode, let's do with the Lewis structures. How to draw the Lewis structures. The importance of Lewis structure, because without knowing the Lewis structure, without drawing the Lewis structure, we can't assign the shape, the polarity. So everything is based on Lewis structure. So it's very important to know the Lewis structure. In AP chemistry, we will learn some more. After the Lewis structure, we need to do with the resonance and formal charge, something like that is there. So basic is Lewis structure. In honors chemistry, you are doing just Lewis structure and shape and the polarity, like that kind of stuff only. Okay, so everything is start with a Lewis structure. So how to draw a Lewis structure? Let's do it. So these are the rules. See, first one, just follow this step. That's the most what easy way to draw Lewis structure, I think. Even though some four steps are there, but I think there is no confusion if you are following correctly the steps. Otherwise, if you are doing polyatomic ion, you got confused. Okay, so let's do the rule by rule, like one step by step, like that. Okay, so what are the rules? First one, count the valence electron, count the total valence electron. And second one, draw the skeleton structure, isn't it? And the third one, distribute the remaining electron to side atom according to the octet rule and then to the central atom. And the last one, check the octet rule for the central atom. If it's not satisfied, do the delocalization. You may didn't get. So let's do with an example. Suppose I am taking CO2. So how to draw CO2 Lewis structure? So what is the first step? Total. Count the total valence electron. So valence electron means valence orbital electron, right? So here carbon. Carbon, the valence electron is 4, and oxygen, the valence electron is 6. There are two oxygen, so 6 times 2. So totally how many electrons are there? 12 plus 4 electrons are there. Okay, and then the second step, draw the skeleton structure. Skeleton structure means, CO2, like that molecule is existing. So if CO2 molecule is existing, which means at least one bond is there. Correct? At least one bond is there between carbon and oxygen. We don't know whether it is one a single bond or double bond or triple bond, but at least one bond is there. Then only CO2, like that entity exists. Okay. So which is the central atom? That's maybe the question or the doubt. So CO2, two oxygens are there and one carbon. So usually most less electronegative atom will be the central atom. So carbon is in between oxygen and carbon. Carbon is less electronegative than oxygen. So usually less electronegative atom will be the central atom. So oxygen to oxygen is there, that is connected to this carbon. Okay, so that is what you mean by skeletal structure. So see, then the third rule says that distribute the remaining electron to the side atom according to the octet rule and then to the central atom. What does it mean? Distribute the remaining electron. What do you mean by the remaining electron? We already found there are total, how many valence electrons are there? 12 plus 4, right? 16 valence electrons are there. So we need to show this 16 electron and this carbon oxygen atoms are there in the Lewis structure. Okay. And out of the 16 electrons, see, by drawing this skeleton structure, how many electron we already shown? See, each bond means two electron. So here one line I am drawing, which means two electrons I'm already shown. Here also one line is there. One single bond means two electron. Two electrons are shared, right? So each of the atom is shared by two electron. So each line represent two electrons. So totally four electron I'm already used. So you can ignore or you can what cut this four electron from this one. Okay. So now distribute the remaining electron means the remaining electron is 12. 12 electrons are remaining. So 12 electron how we arranged? Distribute the remaining electron to the side atom like pendant atom. Pendant atom means not the central atom. So here oxygens are the pendant atom. So to the oxygen atom according their octet rule. Oxygen need 8 electron. Octet rule means every atom require 8 electron for stability. Okay. So 2 electron oxygen already got. Then 6 more electron is needed for getting the for satisfying the octet rule. Okay. So this oxygen also need 6 electron for satisfying the octet rule. So see we have consumed 12 electron now. So we used every electron. If again electrons are there, that is you can add to the central atom. Suppose our electron total counted electron is 18 instead of 16. So here two electrons are there. If it's so, you can put it in the central atom. That's why the rule says that. See the rule? Distribute the remaining electron to the side atom according to the octet rule and then to the central atom. Okay, but here this is not possible because already we assigned every electron. There are only 16 electrons are there. So the third rule is also over. Now what is the last rule? Now last rule says that check this octet rule for the central atom. If it is not satisfied, do delocalization, which means see the central atom, which is the central atom. Carbon is the central atom. See, will it be satisfied? Carbon, is it satisfied? Their octet rule. See, 2 and 2. There are only 4 electrons are there. So carbon is not satisfied yet. So what we need to do? If you want to do that one, yeah, this delocalization. Delocalization means you can show a pair of electron is shifting to this way. Electron movement is called a delocalization. So we need 4 more electron, right? Or carbon have only 2 plus 2. 4 electrons are only there in this structure. So we need 2 more pair. So that's why 2 delocalization is needed. Okay. So finally what you got? Yes, now the 2 line is there. So the remaining only 4 oxygen electrons are there. And here also only 4 electrons are there. That's it. Now see the carbon 2, 4, 6, 8. Now carbon got 8 electron and what about oxygen? 2, 4, 6, 8. Oxygen got 8 electron. This oxygen also got 8 electrons. So everyone is satisfied. That's all. That's how we need to draw with a Lewis structure. Okay. Let's see another example. Suppose instead of CO2, SO2 is the step. Quickly, while we are telling 4 steps are there, but you can just quickly apply step by step like that, this thing. Okay, there is not need much time. Okay, so first step, sulfur. What's the first step? Total valence electron. Sulfur is oxygen family. So sulfur has 6 electron. Oxygen is again 6 electrons, 6 times 2. So totally that much of electron is there. 6 plus 12 electrons are there. What's the second step? Draw the skeleton structure. Again less electronegative is sulfur. So we are drawing one line to the oxygen. So we are used to 4 electron. Correct? So we used 4 electrons. So the remaining electron is what? So minus 4, 18 minus 4. So totally 14 electrons remaining. Correct? Okay. Then distribute remaining electron to the side atom, pendant atom. So 2, 4, 6. And see, 12 electrons are used, but we have 14 electrons are there. We have 14 electrons. So definitely 2 more electron is there. That 2 more electron we need to put it in the central atom. Now see what happened. Sulfur, there are 2 electron and this is 2 electron and this is 2 electron. So 2, 4, 6 electron is there. So again, it's not satisfied. So we can do delocalization. So delocalization means, so you can delocalize this electron to here. So what may be the resulting structure? This one will be the double bond and this is single bond and this is double single bond, correct? So, and see the remaining, this electron is also there. Lone pair of electron is also there. So this is the structure. Okay, but is there any other possibility? See, instead of delocalizing this electron, this oxygen can also provide the electron. So if it's a what, maybe the stuff here, 6 electron will be there, and this is single bond, and see, will be a double bond, and the remaining 4 electron will be there. This is also be the Lewis structure. Okay, is there any other possibility? Can you imagine both delocalization? Suppose both oxygen is delocalizing at a time, then it will be look like this. Correct? So 2, 4, oxygen is also, then the remaining electron is only 4 electron. And see here also 2 electron is there. And here is 2 electron. So what about this one? Is it possible to do this one? Any issue? Maybe you may wonder, but this is also correct. This is also correct. Why? Because sulfur is in the third period. You know that in third period onwards, extended octet rule is there. Extended octet rule means third period onwards, there are 3 shall also be there, which means they can expand the octet rule. They can accommodate more than 8 electron. Here, what is the problem? The problem is here sulfur, surrounding sulfur 2, 4, 6, 8, 10. So together 10 electrons are there surrounding the sulfur. Okay. So no issue 10 electron with a sulfur, because it's okay. They can accommodate more than 8 electron. But oxygen is in second period. So up to second period, they can't accommodate more than 8 electron. So carbon, you can't do like a more than 8 electron. It's not possible. Okay. So sulfur, it's okay. They can do more than 8 electron. And oxygen with the double bond is more, they prefer more double bond, because oxygen need 2 more electrons. Okay, so they prefer always double bond. Halogens prefer one bond, because they need only one electron. So always halogens like fluorine, chlorine, bromine, surrounding them they have only single bond. But oxygen always prefer double bond. Nitrogen means 5 electrons are there surrounding, so they need 3 more electrons, so they prefer triple bond. Okay, so that's why in this structure actually more stable is this one. Okay, most stable structure is this one. But the Lewis structure, when you are drawing this one, the first one, second one, third one, all are correct. All are the Lewis structures. Okay, all are the Lewis structures, but more stable structure may be this one. How it can be more stable, that is actually another topic. It's formal charge. By counting the formal charge, we are telling this is the most stable structure. Okay, simple way you can imagine oxygen prefer double bond. So both of the oxygen getting double bond is in this case. So that is the most stable structure. Clear? But this one is also very correct. You can stop the Lewis structure in this step, the step 1. We don't want to write all the Lewis structures. For one thing, there are several Lewis structures are there, but don't want to do everything. Just you can stop it up to the 4th step. So you can stop here. I'm just telling these are the other possibilities. Okay, that's it. Now let's do for Lewis structures for polyatomic ions. So we already studied what is polyatomic ion. Okay, so it's a group of atom having a charge. Suppose I'm taking CO3, CO3 2 minus. Okay, which means the charge is there. It's not a molecule. Some charge is there. Okay, so here what is the rules are same thing. First rule, total valence electron. Again, carbon is 4 electron, oxygen is 6 electrons, so 6 times 3 is there, so 18. And then see, since it's a charged particle, that charge also have there to contribute. See, charge here -2. -2 means, minus means presence of electron. So -2 means 2 extra electrons are there, not electron is losing. Correct? When an anion means it's gaining 2 extra electron, right? Anion means gaining electron. So 2 minus means 2 extra electrons are there. Electron charge is minus. So minus showing that 2 extra electron is there. 2 minus means 2 extra electron. So altogether there are 24 electrons are there. Okay. Then the next step is same. Quickly you can draw the skeleton structure. So here O3 is there. So again carbon is the central atom. Each one getting singly occupied, single bond. Okay. So this time we use 2, 4, 6 electron. Okay. So you can minus the 6 electrons. So then 18 electrons are there. Okay. So again we are distributing 2, 4, 6, 2, 4, 6. 2, 4, 6. So altogether we used 18 electron. So yeah, and nothing is there to carbon. Correct? Because we used 18 electron altogether. Then what to do? Check the octet rule for the central atom. See, what about the central atom? They got 2, 4, 6 only. So they need two more electrons, right? So again you can do one more delocalization. For any oxygen you can choose. Okay, in this way, how do you draw it? In this way, you can draw carbon. Here it's double bond if you are choosing that oxygen for delocalization, and all other remain 6 electrons. 6 electrons are there, and here there is only 4 electrons. Okay, and what about the carbon? 2, 4, 6, 8. So carbon is also already satisfied, oxygens are also satisfied, like that. Okay, and finally if it's a polyatomic ion, draw a square bracket and show 2 minus, because the 2 minus, 2 extra electron we are already used in this diagram, so we need to show the charge. That's very important. Okay. Okay, in this diagram, can you tell me, is it possible to draw a double bond, and here double bond, here double bond, like that, everything delocalizing and with a 4 electron as we done in SO2 case? Is it possible? So see, here I am drawing everything with a delocalization, and yeah, electrons are same at that time, because I am drawing just delocalization. That dot I am showing like a bond. So electron will be same. Okay. So is there any mistake here? This time it is not possible. This is wrong. Why? Because see the carbon. Now surrounding carbon, how many electrons are there? 2, 4, 6, 8, 10, 12 electron. Carbon is in second group, second period element. Carbon can't accommodate more than 8 electron. The expanded octet is not there in case of carbon. So this is not possible. Okay, if it's a sulfur, then yeah, SO3 2 minus, definitely it's possible. Okay, so that's how we need to write with a polyatomic ion. So another way, this is possible. Okay, instead of delocalizing this oxygen, here it's double bond, here it is single bond, here it is single bond. That is okay. That is not I meant. This is possible. And if you want to use the other oxygen, one at a time, that is possible. Okay, one more diagram you can write. That is, these are actually what we call the resonance. Like double bond is there, here it's single bond, here it's double bond, single bond. Okay, all the single bond, 6 electrons are there, and the double bond, 4 electrons are there. These two are correct, no issue. Okay, but we can't do with this one, so I'm erasing that one. Okay, these three are correct. You can draw like this. This is the whole Lewis structure. Okay, I hope you understood. In next video, we can come up with the other stuff, like after Lewis structure, we need to tell their polarity and their shapes. Everything is there. Bye.